The Unit 1 Day 1 notes has an activity that goes along with it. So what I'll do is I'll do this part up here, which is our introduction, and then you can do the activity and pause the video while I do the activity, unpause the video, and then we'll be at the summary section of it. So let's look at this function called an absolute value function, and you know it's an absolute value function because these bars right here are absolute value bars. And you might remember from Algebra 1 that the absolute value of a number is how far away a number is from 0. So the absolute value of 3 is 3, and the absolute value of -3 is also 3, because the distance from -3 to 0 on a number line is 3. So what we're going to do is we're going to draw a graph of the mother function or parent function, and our x values are going to be -2, -1, 0, 1, and 2. Our y values, well, the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. We can plot those points now. -2, 2. -1, 1. 0, 0. 1, 1. And 2, 2. The absolute value function will look like a V. And the graph has something called a vertex, and that's the pointy part. The pointy part in here is right there, so that's the vertex. The coordinates of the vertex in this mother function is 0, 0. And you notice that you have two lines that make up this absolute value function, or this V. You have this line in light blue, and you have this line in red. So the slope of the light blue line, if you look at it, if you're going from left to right, we're going down 1, right 1, down 1, right 1. That gives us a slope of -1 over 1, or just -1. Looking at the red part of this, our slope going from left to right is up 1, right 1, up 1, right 1. So +1 over 1, or just 1. So you notice that for an absolute value function, when we look at the two parts of the V, one has a negative slope, one has a positive slope. And the graph in this case opens upwards. Up. And the domain, remember, domain is the x values. You can plug in any number for x and take the absolute value. So the domain is all real numbers, or you can write it as -infinity, infinity, because that means every number from -infinity to +infinity. The range, or the y values, that's different. The smallest y value we have is right here at y equals 0, because both sides of this function are going up. So the range is 0, infinity, and we use a bracket because 0 is included. We have a point at 0. Okay. Right, so the first thing we're going to do is explore what does the a value do. The a value is in front of the absolute value bars. And if the actual numeral is bigger than 1, so even if it's -3, okay, that number in front is 3. The numeral is a 3. Or think about it as, if the absolute value of a is bigger than 1, we call that a vertical stretch, because it looks like the function is being pulled up from that mother function. It looks skinnier. Looks skinnier. So that's when the a value, the absolute value of a is bigger than 1. If it's less than 1, so like 0.5 or negative 2/3, we call that a vertical shrink. It looks wider, like the V is very opened. If a is negative 1, now look, it says equals negative 1. Just if it is negative 1, it is a reflection over x-axis. And we could combine that. We could have negative the a value be negative 2, which would be a vertical stretch because 2 is bigger than 1, and a reflection because a is negative. And if a is just regular 1, there is no shrink or stretch or reflection. So now the effects of h and k. So h is the horizontal movement, and it's always the opposite of what you see, and k will move the graph vertically up and down, and it is exactly what you see. So what this means, when we add a number on the outside, the graph moves up, that vertex moves up. If we subtract a number on the outside of the absolute value bars, the graph goes down. If we add a number on the inside, it moves in the opposite of what we would think, so it's going to move left. And if we subtract a number on the inside, the graph moves, that vertex moves right. So that will help us graph our vertex, and then once we have our vertex, we can use the a value as the slope of our two lines, two parts of the absolute value of v, to graph our function.